right, so now let's talk about hypothesis testing for population proportions. So how do we conduct a hypothesis test with population proportions? So we're still always going to want to state our null and alternate hypothesis, okay? And we're going to have to decide whether to reject our null hypothesis or not, and that's us looking at the area right under the curve. Okay, if the area is less than 0.05, we reject at the 0.05 significance level. If the area is less than 0.01, we reject at the 0.01 significance level. So we take our data, find the sample proportion, then we're going to calculate our Z-score for our sample. Remember, this is how we calculate the Z-score for population proportions, a little bit different than population means. We use the Z-score the same way it was used with means, right? And we can compare that to a critical value table or the Z table. This is what I recommend, going to the Z table. This is what Miss Miller recommends. And we need to determine whether we have a significance level. We can reject the null hypothesis or do not reject the null hypothesis. And we can reject the null hypothesis if the area in our Z table is less than either of these. So like I said, if it's statistically significant at the 0.05 or the 0.01 significance level, we reject our null hypothesis. Otherwise, we do not reject the null hypothesis. Remember, there is only rejection. Only rejection in statistics, no acceptance. Just in case you wanted a slide entirely of how to calculate the Z-score for population proportions, here you go. And here's that critical table value. Again, I would recommend going to the Z table. So, suppose a political candidate commissions a poll in advance of a close election. And we hypothesize that our candidate has more than 50% of the vote. So our null hypothesis is always that there's no difference in the claim. So our null hypothesis is that the proportion equals 0.50. And our alternate hypothesis is that our candidate has more than 50% so that our proportion is greater than 0.50. My sample size is 400, and out of the 400 voters, 204 people said they're likely to support the candidate. So I'm going to take 204 divided by 400, and that gives me my p hat, which is 0.51. So now I find my Z-score. Z is p hat minus p over the square root of p minus p 1 minus p over the square root of n. So I have 0.51 minus 0.50 over the square root of 0.50 times 1 minus 0.50 over 400. And I will get a value of 0.40. So I go ahead and I take this value to my Z table. So here we have our table. We have our mean or our center population proportion, and I want to know the area less than this to determine if it is statistically. This is a right-tailed t-test, so I need to know the area over here. This is the area we want. So I look up in my Z table, and I find a Z table value of 0.6554, okay? But in order to find the area on the other side, because this is a right-tailed test, I take 1 minus 0.6554, which is going to give us 0.3556 or something very close to that. I didn't calculate that in advance. Let's check it. So I have 1 minus 0.6554, so 0.3446. Okay, now that's the area over here. Is this statistically significant enough at the 0.05 significance level? No, because 0.05 is less than 0.3446. 0.446. So we do not reject our H naught. For this next example, we have a sample of 750 people, 92 of which are left-handed. Okay, and we want to use this sample data to test the claim that 10% of the population is left-handed at the 0.05 significance level. So my sample size is 750. And in order for my p-hat, I'm going to take the number of left-handed people divided by 750, and that gives me 0.123. My null hypothesis is that our population proportion is 0.10, so 10%. Our alternate hypothesis is that our proportion is not equal to 0.10. So we've got a two-tailed t-test here. I go ahead and find my z-score, which is p hat minus p over the square root of p times 1 minus p over n, which is 750, and I get a z-score of 2.10. And I need the area in both tails. So I take my z-table value. After I take my z-score of 2.10 to the z-table, I get a z-table value of 0.0179. So that's the area in one tail, but I don't have one tail, I have two. So I'm going to take 0.0179 times 2, and I get 0.0358. So because this is less than 0.05, we reject our H naught at the 0.05 significance level.